For this question, we're asked what is the voltage gain in VV from the V3 input to the output for the operational amplifier circuit shown. We can assume the op amp is ideal, and we're going to use the following values. So for this problem, if we look at the notes linked below the like button, we have inverting summing amplifiers, and this is what we're going to be based off of. Additional inputs can be added to an inverting amplifier to create a weighted summing amplifier. V out is the sum of all of our inputs. Each has its own separate gain. All input currents combine at the summing node, which would be right here, where I flows into, and it flows to our RF. And that's how we get this formula. The V out is equal to a negative, parentheses, and then RF over the resistor times the voltage as it's happening over. And we will continue that for however many inputs we have. For this one, we're asked for V3. So with our V3 input, if that's all we want to find, all we need to do is set our V1, V2, and if we had any more, we set them to ground. So if we ground these, they're going to be 0, right? So if we look at our formula then, we should have V out is equal to a negative, and then inside of here, for V1 we have 0, for V2 we're going to have plus 0, because the voltage is here is 0, and it's being multiplied by 0, plus, now we have our RF, which is 36.4 kilo ohms, over our R, and we're going to have, this says Rn, but we can say our R3, and our R3 is 7.8 kilo ohms, and this is being multiplied by our voltage 3. So we have V3 here. And so what we can do is take the negative sign, we're going to distribute it in. We are also going to divide both sides by our V3. That way we get the V over V voltage that's from right here. So that's how we would get that. We want V over V. And then all we need to do is with this negative sign distributed in, we'll have a negative 36.4 kilo ohms over 7.8 kilo ohms. Kilo ohms can just cancel out. We're going to get 36.4 over 7.8 with the negative sign in front of it. If we divide that out, we get a negative 4.667. And if we wanted to find any of the other ones, we would just ground V3 and then solve for like this one right here. And so that is how we would look at this problem and anything like it.